we are going to go into our sequence unit. First, we need to recap. So I have three sets of values here. We're going to start with the first one. So when we look at what's happening to tell whether or not it's linear, quadratic, or exponential, we have to look at what is happening. So we notice on the first one here, everything is going up by 1. Great. It's all going up by 1. So plus 1 each time. If we look here, negative 2 to 2, how do we get there? Well, we add 4. 2 to 6, we add 4. Add 4. Add 4. This is called a common difference. It's how it differs from each one. And when we see this, when it's a constant, we know that this is linear. And in our case here, our common difference would be 4. So this would give us our y equals mx plus b format. Now, if we go to the next one, we notice all these are going up by 1 as we go all the way down, which is great. Now we're going to look here, and we're going to see, how did I get from 16 to 2? Well, minus 14. How did I get from 2 to negative 2? Minus 4. Already I can see these are not the same. Negative 2 to 4 is 6. 4 to 20, 16. And 20 to 46 is 26. So I know it's not linear because it didn't have a common difference the first level, first degree here. So we go to the second level and we see, does it have a pattern? So negative 14 to 4 is plus 10. Negative 4 to 6 is also plus 10. 6 to 16 is 10. And 16 to 26 is 10. Because in my second difference, I had a common difference. This is a quadratic. This is what gets me a parabola. So this is our like x to the first, and this is like x squared. So this is y equals a, whatever that value is, x squared. We just finished our quadratics unit. Okay, so their a would be whatever the value would be. So let's go to our third one. We still notice on this side, we're going up by 1s. Now, if we look 1/9 to 1/3, I don't see any way that I can add or subtract anything to get from there to there. Okay? And if I look here and I see that they're going up by multiples, that tells me that it's doing something where it's being multiplied. In this case, 1/9 being multiplied by 3 gets me to 1/3. 1/3 times 3 gets me to 1. 1 times 3 gets me to 3, and 3 times 3 gets me to 9. So this is called a common factor or common ratio. And when we have a common ratio, we know this is exponential. So this is our y equals a, where our exponent is unknown. So this is a recap. This will help you kind of understand where we're going with sequencing. So let's jump in. We're going to start with arithmetic sequencing. It looks like arithmetic. It's arithmetic. These are used when you have linear and quadratics, so not exponential. So we're looking for something that has a common difference. So we're going to just jump right in. There's 2 formulas you're going to learn. You have to memorize these. In a testing situation, they don't give them to you. So make sure you memorize them. Make yourself a little note card or something of that nature to help you. So if we look at this sequence, we have 20 going to 24, 24 to 28, 28 to 32. Now I can easily say, okay, well, 20 to 24, I know I added 4. 24 to 28, I added 4. I added 4. And if that pattern continues, then I know that I'll add 4 every time. So the first formula we're going to use is called the recursive formula, which is just telling you what's next. What is recurring next, or what comes up next. You don't really need a formula for this. It's pretty easy. If I take 32 and I add 4, I know I'm going to get 36. Pretty simple. However, there is a formula, and you have to know what it is versus what the other one we're getting ready to talk about is. So we're going to look for first the common difference, which we just found is 4. So first we've got to look at what our formula looks like. this is a with a little n subscript. We say a to the n equals a to the n minus 1 plus d. A to the n means what is the next term I'm looking for. So I'm looking for this term that would be right here next. Now, the now term, the n minus 1, is actually what I'm looking for that I know right now. So when I think about what I know right now, I'm looking for the very last one that I know. So this is my 32. So my 32 actually goes here. Then my common difference is what I found. It goes in my D. So the way my problem would look would be a to the n is equal to 32 plus 4, which equals a to the n is 36. This would be my answer. So recursive just means next term. So now let's move on to explicit formula. This is where you can find any term that you want. So if I ask you to find the 50th term, or the 1000th term, or the 100th term, this is the formula you would use. Obviously, you wouldn't want to keep making a big chart and adding that on forever. You lose track. So we have to think of a new formula. So explicit means explicitly which one am I looking for. So this formula, a to the n, is a term we're looking for. So we may be looking for 100th, and we would put 100 at the end. We are actually going to look for the 110th term. So as we do this, we're going to use this example. A to the 1 is the first term of the pattern. In this case, our first term was 20. N to the 1 is our term variable, so what we're looking for, minus 1. We're looking for 110. And then our D is our common difference. Well, first thing we need to know is our common difference. So our common difference, we know, is 4. Okay? Our first term, our a to the 1, is going to be 20. And now we're going to plug it into our formula. So we are looking for a to the 110th. That's what we're looking for. Equals our first term, which is 20, plus what we're looking for, minus 1, and then times our common difference of 4. So now we're going to work this out. So a to the 10th just stays. Obviously 20 can stay. 110 minus 1 gives us 109 times 4. So now we've just simplified down the one spot. Now 109 times 4 gives me 436 plus my 20. And then further, when I put 20 plus 436, I get 456. So in this sequence, if I'm looking for the 110th term, it will be 456. All right, let's try another one. See if you can do this one on your own. So our pattern here is 8, 3, -2, -7. I'm going to give you a hint to find the common difference first, and then I want you to find your recursive, what your next term would be using the formula, and your explicit, I want you to find the 50th term. All right, pause the video, try your work, and then come back and check. Okay, so our recursive, our next statement would be a -7. That's what we know now. That's where we are now. That's our now term. And our common difference we found was a -5. So -7 plus -5 gives us -12. Pretty simple. Our explicit, we're looking for the 50th term. So we plug in a to the 50th, a is 50. Our original beginning term in our pattern was 8 plus n minus 1. Our n is 50 minus 1 times a -5. Notice here I use parentheses to put around my common difference. That way I don't think I'm subtracting 5. And then when I work through, I get the 50th term would be a -237. So this is just memorizing the formula and kind of seeing how it works to find your next formulas. Now, there is a situation where you may need to find a general formula for a sequence so that you can find any term. So the one we're working with, 8, 3, -2, -7, we're going to do this. So we're trying to find a general form to work for anything. So if I told you 50th now, great, you could find it. You already found it. If I told you now I want you to find the 100th, now I want you to find the 1,000th, 10,000. That would be a lot of work. So if you found the general formula, it's a lot quicker to pull in. So this is what we start with. We start with the explicit formula, which I already have written down. We plug in our known values. We already know that our common difference is a -5. And we know that our first term is 8. Now we're doing a general formula, so we're not finding anything. We're just trying to make a formula for later that we can use. So our a to the n is going to stay that way. Our first term is 8. And then we know that our n is going to stay because we're going to use it for anything that we can find, -1, and then we're going to have a -5. So now we're going to simplify this down. This turns into 8. Now here is what happened is we're multiplying. So we really have plus a -5n, a negative and a negative give me a +5. And then I'm going to simplify down. Well, this is just a number and a number, so I can put those together. And then this is a number by itself. So a to the n will give me -5n plus 13. So this formula is a general formula, explicit formula, to find any number sequence. So now if I told you to find the 100th term, I can just plug in 100 into the n, and I could easily find out what that would be. So it's a much quicker way when you're finding a whole bunch of different terms with the same pattern to save yourself some work. So this is finding a general formula for a sequence. Now, our procedure, we want to always find the common difference. That's going to mean that it's arithmetic. And we're going to write the formula, plug in the values known, and then we're going to calculate it. You have some practice to try? Give it a try. Keys provided.